Hey, Jake. Hey, Jake, look at this.
Jake? Who's Jake?
uh,
You know,
anywhere, yeah.
I think I said something to Zach to the effect of because my son, has been accepted to Buffalo School of Engineering.
Gotcha.
And, we went there, I think, like a week ago. We got pictures and stuff like that.
That's fun.
And Zach was gracious enough to offer, hey, if it was possible, I would show him around, and but it's not feasible right now.
Yeah.
And I think I said something snarky in response to like, yeah, the real trick to getting Noah into Buffalo, hey, I know Paul Deem or something like that has worked throughout my whole life. Zach didn't even catch on the whole Paul Deem reference. I think
That's
he just
funny.
was being polite and sweet about everything else.
It looks like Jake's getting on now. He changes his name every few years.
As long as it's not Jake Paul, we're okay.
He was Paul in college, and then I came to Lockheed, and he's like, I'm Jake now.
So it's you, he who changes his name, and
Yes, and then we'll have a few other engineers. There should be Carrie, and then who you have not met, and then I believe, let me see, is Cecilia. And then mechanical engineer named Cecilia. She
Okay.
should be here too. So hopefully they're able to get on soon.
That's cool. Like I
And
said,
you can see my PowerPoint.
yes, it's perfect.
Okay, awesome. So I know Carrie's going to go over the beginning of it.
If we have limited attendance, even then, it's recorded and rebroadcast, so I'm happy no matter what.
Yeah.
I'm checking right now. I have a doctor's appointment at 1:30, so if I run out of here at 1, but I don't see it going that long.
Oh yeah, no, we'll have to stop at like 12:55 probably.
That's cool.
Or not 12:55, 11:55. Right. So, because we have another session, the Liverpool.
All right,
one.
Liverpool.
Yes.
We could not admit Jake Deem.
Let's see. Did you get in, Jake?
I clicked admit.
I clicked admit too.
We're learning machine learning in AP tomorrow.
Oh wow.
Yeah.
That's good. Maybe they can teach me. I'll ask Liam.
I'm not the one teaching it.
Oh really?
I know the absolute basics, but I have a former student who has made a neural network for a project when he was in 10th grade.
Oh wow. Okay.
Yeah, he's kind of smart. Did you know any of the Georgiadis brothers?
No.
Maybe
Oh, Jake quit.
Um,
Let's have him enter again.
This is the youngest brother. Super bright, but yeah, he's presenting on machine learning and neural networks and AI.
Oh wow, that's cool.
He made a thing that recognizes handwriting when you write it, like, hey, that's an 8 or that's a 9.
Oh wow.
It's cool.
All right, I'm back.
Hey.
Can you hear me, Harbinger?
I can hear you.
Yes.
Hey.
Turn your camera on, Jake.
Oh.
We're allowed to have him on in here.
Yeah.
Yeah, I just muted YouTube so we don't have the echo effect we had yesterday.
Okay, nice. Hopefully there's not too much echo between me and Jake. 1 second.
So Jake or Paul?
Oh, thank you. Jake. Nowadays, at least.
That's great. Yeah, I made a comment to your brother that, what got my son into Buffalo for engineering was that he knew Jake Deem. And that always seems to work. And Zach was way too polite to make a joke back, or I don't know.
I don't know. I don't think you would have gotten in if you mentioned my name. I'm just kidding.
Well, Zach, I asked him, I said, hey, we'd like to take a tour, but everything's closed down. What should we look for? Because we just drove around the campus twice now.
Yeah.
He wrote this like super long essay about, and it was so well thought out and insightful. What I think about when walking across campus, and here's something. If you guys didn't know, Jim Smith retired on Friday.
Oh, really? Wow.
Actually, 2 Fridays ago. So I was in mourning for a week, and I still am.
That's funny.
He already
Did that coincide with the middle of the year?
Yes, he retired January 29th.
Nice.
He sent in a card to the faculty room thanking us for the gift. And of course, it's classic Mr. Smith. The whole thing is like, The first thing I did was get rid of cable, which is the biggest scam right now. He said when COVID goes away or becomes like the situation becomes more normal or livable or whatever we're dealing with, he wants to sub just to be here more, but
Sub for your class only.
said he would, which is awesome. And this is our virtual day. So we have no students in person.
Gotcha. I was wondering how that worked.
Yeah, today's like right now I'm technically in office hours.
Okay.
So if you want questions, like somebody came on and asked about lists, how lists work.
Yeah.
This
Never.
year I'm teaching AP Comp Sci principles. So it's a different class than the one you guys took.
Okay.
But definitely more of like an intro level.
Gotcha.
But we had a code unit. We have a how does the internet work unit.
Oh, that's cool.
Cybersecurity unit. Big data. We're finishing big data.
Do you know how I look at the chat in this stream?
Oh, in the YouTube stream?
On the YouTube stream, yeah.
I do not. I don't see any comments, but we have 7 people watching, so I'm taking that as a positive.
Oh,
Yeah.
I see. So they're gonna sign on to YouTube and then.
And then chat with us.
Well, I was concerned about scalability. The optimistic
Yeah.
view was like, what if we get 2,000 people and Zoom is limited to 100 or 200, and I'm not paying money for Zoom. I mean,
yeah.
have the district pay for it.
so I put us on YouTube just in case. And like I said, I know it records automatically, so I'm happy. The other
Oh,
thing,
it looks like live chat is turned off.
oh, okay. How do I
It
turn
doesn't
that?
work
Oh,
well.
it says because the content is made for kids.
Yes, that's true. So what goodness gracious, can I fix that? Maybe. Hold on. I usually have for kids by default, just so it's
Yeah.
worry about. I mean, worst case scenario is we talk and they can email.
We talk.
They email you the questions.
Okay, I'm looking for how to change my settings, which is funny. I saw it yesterday, and of course now not there. But restrictions. Okay. See, no, it's not for kids. Although I'm encouraging local high schoolers to log on, and here we go. I've now changed permissions, so it should be enabled soon. Maybe. I have 2 master's degrees. Getting onto YouTube should not be this difficult. It absolutely is. Okay, so it looks like chat's enabled now. So
I was able to load it, but I didn't see anybody chatting in it. Whoops.
Okay.
Oh, I just.
all right, so we have at least one person there, Brian. Jason, I'm laughing because you make me smile. So thank you, Brian and Jason, for being here. Thank you for throwing that in the chat. It's nice to see people chiming in. Jake, if this helps, not everybody has to chime in clearly because I hope that we have so many people it's not tenable. Jason's my current student here at CNS, takes a lot of the computer science courses. He's kind of okay at programming. His passion is mechanical keyboards, if I'm not mistaken. And Brian reminds me of your brother academically, if that helps. Super motivated and on top of a lot of stuff.
So not like me.
You were only fourth, right?
Yeah. Third.
No. And hi to
You're
Carrie.
muted. You're
I don't
muted.
think we've had the pleasure of meeting. So I see Carrie too. I'm waving, I guess. I'm not sure how intros thing work, but I'm going to nag Carrie to talk if that's okay.
Sure. We'll go through the PowerPoint in a second.
Oh, do we have to wait our turn? Like, oh, sorry, I can not talk.
No. Is it? I guess we can just start going through the PowerPoint now. It looks like there's an echo. We should probably have.
My YouTube's muted.
I'm gonna let Carrie go ahead and go through the intro. So Carrie will go through the intro now.
All right. So hi, everyone. Welcome to our engineering panel discussion. I'm going to give sort of a brief overview of what Lockheed is and what we do here at Lockheed Martin Syracuse before we go in and answer the great questions you guys have for us. So starting with our first slide here, what is Lockheed Martin? So Lockheed Martin is an American aerospace, defense, armed security, and advanced technologies company. It's headquartered in Bethesda, Maryland, and employs over 100,000 employees worldwide. So we're operating in about 40 countries. So that includes Australia, Canada, the UK, and even Germany, just to name a few. We consist of 4 main business areas: aeronautics, missiles and fire control, rotary and mission systems, and space systems. So I'll give a brief overview over what those business areas are. The first one is aeronautics. So this business area designs, builds, and sustains military aircrafts, and we've been doing so for more than 100 years in that business area. Then we have missiles and fire control. This business sector develops, manufactures, and supports advanced combat missile, rocket, manned, and unmanned systems for the Army, the Navy, the Air Force, and the Marine Corps, as well as NASA. Then we have rotary and mission systems. So for this business area, which we do here in Syracuse, we provide surface, air, and undersea applications for the US military and a number of international customers. And we'll talk a little bit more on that in the next slide. Then we have space systems. So this sector deals with global communications, weather forecasting, exploring space, and national security. All right, so narrowing it down to what we do here at Syracuse. So Lockheed Martin Syracuse is a part of the Rotary and Mission Systems business area, otherwise known as RMS. Here we have various programs that focus on designing, building, and maintaining electronic systems that operate on military ground vehicles, submarines, ships, and helicopters. So I have a few pictures here that reflects just a few of the things that we do here at the site, including ground-based radars, I'll explain what that means, and submarines. So the 2 top pictures show examples of what we call a ground-based air surveillance radar system. So a radar system is just a detection system that can be used to detect objects such as aircrafts and missiles. On the top left, we call that the TPQ-53, and the job of that radar system is to detect, track, and determine the location of where an enemy is firing a weapon from. And then on the right, we have what we call a TPS-77, which has a similar job, but it's a different design and has a different set of capabilities. On the bottom is just a typical submarine used to represent the underseas programs that we do here at Syracuse. For those programs, we design and build systems that we install on the boats that can be used to detect, identify, and analyze, as well as report very important information back to the individuals that are operating the boat and the system. So that important information could be possible threats, whether in air or undersea. We also have, oh, I'm sorry. We also have quite a few customers here at our site, which includes the Army, the Navy, and the Marines. Yeah. All right. So what does engineering look like? So in order to carry out a lot of the work that we do here at Lockheed, I'm sorry, it requires a variety of engineers. So the ones we have listed here are systems engineering, mechanical engineering, software engineering, and electrical engineering. And that's just to name a few. There are a ton others that we can go over later during our discussion. Um, so systems engineering focuses on how we design and manage very complex systems over their life cycle. So that life cycle would be the idea or plan for the system, designing the system, maintaining the system, and then once it's got into a certain age or we're no longer in need of that system, it retires and we dispose of it. Then we have mechanical engineering that deals with a variety of machines, generators, engines, the air conditioning in your homes, and the elevators that you use almost every day. And then we have electrical engineering that has to do with designing and application of equipment, devices, and systems that use electricity. And there's a ton of things around you that use electricity and electronics every day. And then lastly, we have software engineering. So that includes just the development and building of computer systems and software applications that you encounter on your phones or on your computer every day. Yeah. All right. So why become an engineer? Simple. It's fun. It's exciting. It's challenging. There are a bunch of jobs that you can do, and you can work at a place like Lockheed. It's also very fulfilling, and what a lot of people like to take note of is that it's considered a high-paying job. That shouldn't be your only reason why you want to go into that field, but it is one of the big notes on that. And then how you become an engineer. So you find a community, you look online, you find different activities that have to do with science and math and engineering. You do your research and you find out, okay, do I want to do electrical engineering? Do I want to deal with circuit boards? Do I want to go into computer engineering? Do I want to deal with, creating gaming systems or anything like that? You also want to focus on STEM. So STEM is science, technology, engineering, and math. So when you're in your classes and when you're in your school and you're thinking about, okay, what does chemistry have to do with what I'm going to do in the future? Or you might want to become a chemical engineer. Or what does, my physics course have to do with anything? Or your computer science course have to do with anything? So you want to think about the classes you're taking and think how they may connect with those engineering disciplines that you've researched online. And then explore and do. There's a lot of projects out there that creating a circuit board, simple projects that give you a taste of what you could be doing out in the real world. And then just a matter of believing in yourself. Engineering is thought to be a very challenging career, a very challenging discipline. But if you put yourself to the plow, so to speak, and you believe in yourself and you just push forward, you can do it. Anyone can do it in engineering, no matter how hard people think it may be. All right. So we're gonna go into the panel discussion and I'll reintroduce myself first. So my name is Carrie Crumby. I work here at Lockheed Martin Syracuse as a systems engineer. I went to school for electrical engineering at RIT, otherwise known as Rochester Institute of Technology. I've done other engineering forms such as integration and tests, firmware, and hardware engineering in underseas programs and ground-based radar programs. When I'm not at work 10 hours a day, I'm participating in Kaneko and karate. I'm a blue belt, and I'm doing kickboxing and playing the guitar.
Looks like I'm up next. So I am Kyle Spivak. Hello. I did go to CNS, and Mr. Harbinger was my teacher, or Matt, as I now call him. And then after CNS, I went to the University at Buffalo, and I got a BS in computer engineering. My current role at Lockheed is I'm a software engineer for ground-based electronic warfare program. So I mostly code in C++, but also you need to be fluent basically in Linux, knowing how to navigate through a terminal and do all those fun commands and such. Some of my past roles at Lockheed, I was a software engineer for a C-based electronic warfare program, and I was also a software engineer on an RF Spectrum IRAD, which an IRAD is internal research and development, so something that was funded by Lockheed. Some of my personal interests are rock climbing, video games, soccer, and I've recently started playing chess. And then this is my cat here. His name is Tucker. He is great. And that's the rock climbing gym I go to. So that's all for me. We'll go to the next person.
Hi, everyone. My name is Cecilia Cato, and I started here at Lockheed, my full-time position at Lockheed back in July as a mechanical engineer. I graduated in May of last year at Clarkson University with a bachelor's degree in mechanical engineering. My current role is that I'm working on a Stryker vehicle, which is a ground-based radar with electronic warfare, I believe. And the hardware design that I do for that is where the interface of the operators in the vehicle. So I design all the things that they touch and work with. A past role that I've had at Lockheed is in my junior year of college, I took a semester off to do a co-op. And I did electronics packaging for the Blick 10 program, which is the submarines that you saw earlier in the slides. Electronics packaging includes all the hardware that goes around where all the software sits, essentially. So all the different servers that go into that submarine, there has to be some sort of hardware and mounting to hold that in place. And then outside of work in engineering, I like to downhill ski, water ski, golf when it's nice out, and just anything out on a boat in the water, which you can see in the pictures that I provided on the slide.
Hey everyone, I'm Jake Deem. I also went to CNS through high school, taking Mr. Harbinger's class in 2014, I think. I then went to the University of Buffalo. I got a BS in electrical engineering, and I graduated there in 2019. And then shortly after, I started work here at Lockheed. So I've been with Lockheed for about a year and a half now, coming up on 2 years in June. I also took some classes along with the other ELDPs at Cornell University through the internal project that we take here. And then now I'm pursuing a MS in electrical engineering at Georgia Tech. Right now, I'm currently a radar systems performance analyst for a next generation air surveillance radar. So this includes like modeling and simulation, a lot to do with MATLAB, simulating our radar and how well it can perform against certain coverage requirements. Some past roles that I've had have been radar hardware integration and test engineering. That was for like a prototype testbed radar. That was pretty fun. That was like a very hands-on type rotation where I was able to get a feel for the hardware and the software that come together to make a system like that. And then I've also done some radar hardware production test engineering for a short-range air defense radar, specifically a digital processing unit that was a cornerstone of that system. So that was fun. So personal interests I have, I like to do a lot of hiking, camping, outdoor stuff, snowshoeing and sailing when the seasons call for it. So a lot of those pictures are in the Adirondacks.
And then unfortunately, one of our engineers who was going to be here, he had a meeting come up, so that does happen sometimes. So he will not, he's not going to be able to be here, but that was his slide that you briefly saw. Okay, so now we're going to open it up to question and answers. Looks like we have a few people in the chat already, so if you guys have any questions, let us know. And if not, we can just start answering random questions. Let's see.
I know the YouTube video is a little bit delayed, so
Yes, it is.
give it some time.
It's about like 15 seconds delayed, I think. So I can answer a question you're all thinking, yes, I knew Jake at UB. And yes, we were roommates 1 year.
Okay, I have a question then, since people are probably still thinking of things, and a lot of this is just recorded for, broadcast later on to a bigger audience. Can each of you talk about a little bit, please, being young professionals, how you balance work life with non-work life? I know when you're first starting off, or even later on, it can be difficult to juggle both those things. So can maybe you talk about how you balance that aspect?
Yeah, just don't sleep. No, just kidding. I guess I can go first. So something I've been doing a lot recently is rock climbing. So I think it's good to get kind of in a schedule of kind of just like habits that you like to do. So I found rock climbing before rock climbing I would do, there's pickup soccer at Lockheed. Also just making sure that you don't work too much. Try to not work on the weekends, I guess I would say. It does get hard, especially when you're balancing, if you're doing a master's degree while you're in working full time. So you kind of just have to find something that works for you and try to make sure you give yourself times to not get stressed out and make sure you have time to de-stress. And I guess one other thing that I find that's really helpful is surrounding yourself with people who are going through the same things as you. So all the panelists here are ELDPs, which stands for Engineering Leadership Development Program. So we're all going through the same, getting your master's while you're working full time. So it's nice to be able to talk to them and you can kind of share your experiences and complain sometimes. I don't know if anyone else has anything they want to add to that.
Yeah, I can jump in. One of the things that Lockheed Martin moved to recently was a 4-10 work schedule. I feel like that helps a lot. We have essentially 4 days working 10 hours, and then we have every single Friday off, which makes a nice 3-day weekend. And so that aspect does help with separating work from personal life. Apart from that, I mean, when you're in school, you've got homework. You don't have homework when you're working. If you can kind of set yourself a start time and a stop time for every day, get into work at 7, get out of work at 5:30. You can do all of your work during the day and not feel like you need to either bring your computer home or open up your computer at home, and then just kind of force yourself to make that delineation.
Something that's kind of difficult right now with the work-life balance is working from home with this new time that we're in. I'm working from home, and it does make it easy to work longer, work on like the off days or the weekends. I try to make a habit of when I'm done for the day, shutting off my computer so I don't look at it, like shut it completely down. And I also make plans for the weekend ahead of time so that I have something to look forward to or keep me from thinking about work. But definitely right now is important to make sure you have that line between work and life when work is where you live.
So I'd say I agree with everyone else. The culture at Lockheed Syracuse really does help that life work balance. I'm very guilty of bringing my laptop home and sneaking a peek on a Saturday or a Sunday. I'm trying my best not to do that anymore. It's hard sometimes, but I schedule in actual time. So I'll say 5:30, I'm going to kickboxing. No matter what happens, I'm shutting down the computer and going. And so that sort of helps in that life balance.
Yeah, I think that was all great. Do you have any follow-up questions on that for anything we said, Matt? I see we do have questions in the chat.
Sorry, I had a million questions, but I'm so excited to see questions coming through the YouTube chat. So I definitely would prefer to hear from the chat questions.
Okay, so we'll answer Karen Petrella. Sorry if I messed up your name at all. What does a typical day in the life of an engineer look like? So this will be different for every type of engineer and if we're working from home or not, but I'll start as a software engineer. So I'd say a typical day is I get into work, I check my emails, see if I have any new emails, if I broke anything, if the nightly build broke. Sometimes that does happen. And then usually I'll check. So we use Jira here. So at least my team is an agile team. So that might be something that maybe you've learned in AP Computer Science, or maybe you've heard, but Agile is a type of development strategy, I guess I'll say, where you basically work on kind of a task at a time and your team updates you on your task status pretty frequently. So I'll usually check in on whatever task I'm working and then just start working on it. And then around like 10 o'clock for me, we have our Scrum meeting, which is also part of the Agile team and development style. And so we actually have two on my team. And the first one, I'm just a participant, but the second one, I'm the Scrum Master. So I am leading the Scrum, trying to make sure that everyone stays on topic and we get out of the meeting in a timely manner, because meetings can really eat up your day. Especially you might have one or two and they're an hour long and maybe they go over to an hour and a half and then 3 hours of your day is gone. So they can eat up your day. So we try to keep the Scrum meetings short. And then after that, it usually looks like just working on code and any meetings that come up, any collaboration I need. Usually we use Skype here, so usually there's a lot of desktop sharing. Sometimes there's some pair programming. And yeah, I'd say that's pretty much a normal day, is getting on emails, starting work, Scrum, and then working on stuff, just code for the rest of the day, trying to finish my tasks. Whoever wants to go next is, we don't really have an order, I guess.
I can go next. So my typical day is sort of similar to Kyle's. I come in the morning, check on my emails, see who's yelling about what broke the night before, which is often. Then I also have Scrum, so I plan out, okay, this is what I'm going to do for the day. This is what I'm going to work on today, aside from whatever issues that may pop up in the lab. So I head to the lab, and I'm an integration and test engineer, so I'm the one that's looking at code like people from Kyle, and trying to figure out what they could have broke, letting them know that this is what needs to be fixed, and integrating that software into the systems out there. And then pretty much I'm out in the lab all day, which is fun. It helps the day go much faster, just solving problems, integrating systems, and assisting software folks in testing their stuff.
I can hop on now. I'm doing a lot of radar system analysis and requirement analysis right now. So part of my job is to kind of take a look at the requirements that we have laid out for the system. These could be any sort of requirements that govern the system. I deal mostly with the performance requirements. So what I do is I generally I work with a team. My team lead determines which requirements are the most pressing at the time, and he flows those out to us. We take a look at those requirements and perform analysis or develop tools to analyze certain requirements and how we have our system laid out. So this is a lot of my day is in MATLAB. Using tools that we have developed, signal analysis tools, digital signal processing, a lot of probability and statistics modeling, and we're generally developing the tools and then using the tools to determine compliance against customer requirements. This also involves having like status meetings here or there, or meetings to present certain material when you've finished a certain task.
I'll add on to say that a lot of my day also consists of emails and status meetings. But from a mechanical standpoint, I spend a lot of time doing 3D CAD models and working those. And then because I work from home, whenever I have questions, it's all phone calls. So I do get on the phone a lot with people throughout the day and just share my screen, show what I'm working on. But for the most part, all of my work's done 3D modeling.
I thank you guys. I would like to also point out, if it feels like we're being vague, it might be because we are, because a lot of us do work on sensitive information. Since we are working for the government, some of us might even work on classified stuff. So if we're being vague, it's for a reason. So yeah, I guess we'll go to the next question. What is the requirement to work there? How hard is it to get a job? So I'll go from a software engineering perspective. I think the most common path to work as a software engineer at Lockheed is to get a 4-year degree. I believe Lockheed does hire people who have associate degrees. It's definitely harder to get in with only an associate's degree. I would recommend a bachelor's degree for the path of least resistance, unless you're a coding god. Besides for that, I would say probably a major in something like computer science, computer engineering. I've even seen some physics or some math people get software engineering jobs. So definitely something in STEM for sure. If you've developed your skills, sometimes if you have a lot of personal projects, let's say you're a mechanical engineer or an electrical engineer, but when you got to your higher level courses, you kind of realized you like the coding aspects. Well, if you do your own personal project in some sort of coding project, you can put that on your resume, and that does help a lot with trying to get a software engineering job. How hard is it to get a job? So I don't know this exactly because I'm not part of the recruiting team, but I know I can tell you about what happened for me. So I applied to be an intern during my sophomore year of college, and between sophomore and junior year was my first internship here with Lockheed Martin. Then they asked me to come back for another one. And then after the second internship, I was graduating and they offered me a full-time job. So the only time I actually interviewed was for the first internship, and that was basically they brought me on to the site and I had 3 different interviews, each like 20 minutes long. One of them was a coding interview where they had me answer, not gonna lie, very easy question. I don't know if it was because I was an intern, but I think it was, actually, I don't know if I'm supposed to say, but if you look on I'll say some websites out there that might show you salaries and common interview questions, they may or may not be accurate. But yes, at least in my experience as a sophomore intern, the coding example was very easy. I know I've talked to other people who applied later in their college years, and they had different ones that were a little bit harder and were more object oriented. Sorry, getting a little off track. So how hard is it to get a job? I'd say if you do well if you do a 4-year degree and you do well in your 4-year degree and focus on actually learning, and maybe not just getting good grades, but actually learning the language, learning the concepts behind it, I think you'll have a pretty easy time getting a job somewhere. Maybe it might not be Lockheed, it might be some other software development, but I'd say the job outlook, and this is without actually looking, this is just my guess, the job outlook for software engineers is pretty good in the US. Now that I've rambled, I'll pass it on to, I guess we'll go in the same order, Carrie, if she's ready.
Yeah, sure. So for me, getting into Lockheed, it was sort of backwards. I applied through their recruiting event at my school my final year of college for a full-time position. And then I realized that I needed a requirement for a co-op. When you go to RIT, there's like a internship and co-op requirements. And I said, hey, I'm going to need a co-op to graduate. And they're like, yeah, sure, we'll give you a co-op as well. So that was sort of backwards in that way. How hard is it? In my experience, it wasn't too difficult. I applied for a systems engineering position. So for that position, you can have a variety of backgrounds, electrical, mechanical, because it deals with just integrating different parts of the system. And my interview process, I interviewed also with 3 different people, and mine wasn't very technical based. It was more situational based, like, oh, tell me about a time you worked with a group of people and maybe you guys didn't really get along. How did you solve that? Or tell me about a time in which you had a difficult project. How did you get through that? So mine was really what they call star based situation questions. Was there another part to the question I missed?
I think it's important to find how hard it is.
Gotcha. Okay, yeah. So for me, it wasn't really hard. And to piggyback off what Kyle said, it's really just, having the good grades, having maybe some experience if you've interned somewhere else before, or even showing that you had side projects, right? If you're in software and they see that, oh, I learned Python, I taught myself. And they're just like, wow, a self-starter, someone who's able to learn, who can learn things quickly and apply it. They like to see things like that.
Yeah, so requirements for the job, I believe, they look at your grades somewhat. I think if you have at least a 3 or a 3.5, or yeah, 3.3, I think, in college. I think that's sort of like a benchmark you can aim for. But yeah, I think like Kyle said, I'm not part of the recruiting process, but the more you can beef up your resume with internships, with co-ops, with experiential learning, like just extracurricular clubs, with any side projects you can do, I think that really beefs up your potential for landing a job. I think the other big thing is getting the interview for a job. That's a key right there. Definitely utilize the like career fairs at your college. A bunch of employers go to career fairs, and that's your time where you can go up to potential employers, talk with them, give them your resume, and then they'll remember you. They might be able to give you an interview right there. So that's something to remember. Yeah, I think that's pretty much it.
Just to wrap it up, they all hit great points. But in terms of how hard it is, it all depends on how hard you want to work for it too. And because getting a job, you are selling yourself. In the interview, you have to talk about how you think you are good for the job and how they should want you. So it's not all about grades. You have to show that you are capable in academics, but also that you have people skills, teamwork skills, that just you want to work, you want to learn, you want to, because they know, especially it's hard when you first, I felt this recently, that fresh out of school, you think that you should, be up here and know so much, but really the employer knows that you really don't know that much in the grand scheme of things. So you have to show that you do, that you want to learn and that you're willing to learn and grow. So just telling the employer that you're the best option. And when you take it in that approach, it's not that hard to get a job.
Great. And I think a few of us hit on the pretty critical point of knowing that you always have more to learn and being willing to learn more and being excited about learning more. I think that's something they definitely look for. I know Carrie mentioned the STAR behavior interview questions. I had those as well when I didn't have my technical portions. So thanks for the question, Liam. We'll go to Jason. How much of the work you do is self-taught and how much of it is learned through school? Okay. So for me, as a software engineer, I learned a lot of it in school. So you kind of learn the basics in school, almost like learning how to learning the basics of coding, kind of the logic. And then you kind of learn on the job, but also learn in school. That was a hard one to answer. I'd say for me, I learned a lot of it during school, but maybe I was doing clubs. Like I would do different clubs. Like there was a nanosatellite club at UB that I was a part of. There was a IEEE club that I was a part of. So I think making sure you learn as much as you can at school will prepare you for the job. But even when you get at your job, there's always going to be more to learn, especially from a software aspect. I think once you've learned, maybe not mastered, but once you've gotten pretty good at one programming language, for the most part, it's usually not too bad to switch to another. It's mostly syntax at that point in my mind, which you can Google pretty quick. So I would say I learned a lot from school. Maybe some of it was self-taught for projects and stuff, like going a little bit beyond what the requirements are. Um, and then also learning on site on the job. So hope that answers your question. Another ramble. We'll go to Carrie next.
All right. So, being in the systems engineering field, I learned, and with a background in electrical engineering, I learned a lot of stuff in school. I did some side projects. I was involved in some extracurricular activities that helped me to apply those things and to be better at them. But for the most part, with systems engineering, because it requires more than just an electrical engineering knowledge, a lot of it is on the job learning. A lot of it is specific to Lockheed Martin or just the defense industry in general. So I'd say it was a bit of both and a little bit self-taught.
Yeah, and I'll say I want to say that the education you get through your university is at least in electrical engineering, and then subsequently like RF, microwave engineering, and digital signal processing. A lot of the coursework you take, a lot of just kind of lays the foundation for knowledge to learn on top of that. Like for example, when I went through college, I learned a lot of calculus, a lot of physics, a lot of system theory, signal processing type classes. But once once I got a job here, especially in RF and microwave domains, I had never taken a class in that in undergrad, so I learned a lot of that on the job. But I wasn't going to be able to learn that had I not had like a circuit analysis class or a circuit theory class or a system theory class. So a lot of what you learn in school will provide the foundation, will allow you to learn quickly. And then once you start working in the job, you'll find that you're still learning a lot, but you're only able to do that with that foundation you got at school.
For me, in the mechanical field, mechanical is very broad, and going back with what Jake said, that your schoolwork is your foundation, is your base level. You get all the fundamentals, but at least of what I'm doing right now, I don't refer to like my textbooks every day. I don't refer back to those specific things that I was learning in the classroom. But those basic principles are still there that I use every day. And problem solving, a big thing that's especially college teaches you is the problem solving skills, because it doesn't matter the specific question that you're answering, but the overall basis of the question and how you attack the problem. And that's what engineers use every day, is those problem solving skills. And I have sprinkled in some of my own self-teaching in, at least at Clarkson, they didn't require us to mechanicals to do any sort of machine or shop classes, but they offered them on the side. My sophomore year, I went and did a few of those classes, and then it ended up helping a lot when I got into my first internship, where the company I worked for did all their manufacturing right there. So I had a good understanding coming into that. So it is a combination of doing some what interests you, going out and finding those interests and teaching that or learning yourself, but also every day in the job you're learning. You never stop learning, even when you're close to retirement.
Yeah, I think those were all some really good answers. I know I also took some classes that were outside my domain. Like I took a MATLAB class just so I could know when the system engineers were complaining. It really wasn't that hard. Um, no, just kidding. Um, yeah, no, just kidding. I did take a MATLAB class though, and it was so throwing some shade. The civil engineers I had civil engineering friends who complained that that class was the hardest class they ever had to take, and if you know how to program, it was not hard. Um, yeah. So looks like we might be out of questions. We
No, I
definitely
have
have time
one.
for another one. Okay, looks like Mr.
All right.
Harbinger has a question.
I've got one. I've got like 10, but I know that time is an issue, and I'm trying to be conscientious of that. And I'm trying to find a question that would be very difficult. Sorry, very different for each of you.
Okay.
In light of your different fields of expertise, a software engineer might have found COVID to be not as impactful or working remotely, like as less impactful on their regular everyday job versus like a mechanical engineer. Cecilia, I think you talked a little bit about like the 3D modeling software you use, but I don't know if you're an engineer who like gets their hands dirty. Is that the way to say it? A systems engineer, electrical engineer, like I'm sure all of you have had your jobs impacted in some way. Could you guys talk a little bit about like the last year, maybe how that's impacted you guys professionally? And maybe that's
Yeah.
how that changed your job role?
I can go through that really quick. So when COVID started, I did go virtual. At that time, I was working the IRAD program, which was unclassified. So I was able to do most of my coding from home, and I was actually testing on some SDRs, which are software-defined radios. So I was lucky enough to be able to bring those home and test from home. So that was my experience. And then I actually switched programs as an ELDP. You do rotations, so you work on different programs. So I switched to my current program, the ground warfare or ground electronic warfare program. And that one I also was able to do mostly from home, but we actually have a demo in Arizona that I'm going to next week. So for that, I've been coming into the office more just for sometimes it's faster collaboration, sometimes it's testing stuff in the lab. So for me, it was mostly working from home, and then towards the end, as things got better, I was able to come to the office. And most of the time when I needed to come to the office was to work on things that were in the lab or that I needed a physical connection to in order to do my coding. So I'll pass it on to, we'll do the same order. So Carrie.
All right, so throughout COVID, I still had to come in because I work in a classified lab environment. So I was still coming in every day. But what made it slightly difficult is that we did have software engineers that are working from home. And so, having to IM them, having to call them and converse about the different issues that I was running into, that did make things a little bit more difficult. But for the most part, my job wasn't very much impacted by it.
Yeah, so when COVID started in middle of March or so, at that time I was working on some legacy ground-based radars that were, I was able to work on that from home, but around the end of April, I switched programs sort of to a different next generation radar, which had a lot of classified work. So I started coming in at the end of April, and I have pretty much been coming in ever since. And then around the September-October timeframe, I needed to switch quickly to an integration and test sort of role for some production testing that was happening in Florida. I had to travel to Florida during that time, and so that made it a little bit difficult when I had to come back and quarantine. Even though a lot of my work was at, I had to go back into the office, so it was a little bit of a tricky situation there. But when I'm not when I didn't have to travel, coming into the office was I was coming into the office a lot, and then it made it easier, I think, for like separating that work and personal life situation.
For me, I started my position in the summer, so I didn't even have a chance to go into the office at all. My first day was from home, unfortunately, which I don't recommend starting a new job in this situation. The learning curve has been steeper because of it. But luckily with technology, everything that I do can be done remotely. And when I just need help, we have the ability to share a screen so someone else can see exactly what's on my computer. Unfortunately, personally, I miss working with someone in person and drawing things out and on a whiteboard and talking things through rather than just trying to use your mouse to show somebody on the computer. And some of the equipment that I work on is on site, so I've only gone a couple times to see it. But if I was there in the office regularly, I would be going there more often, and it would assist my work a little bit more, but I am limited to when I come in. So I haven't been, in terms of like what I am doing right now, it's doable from home, just makes it not as easy.
Awesome, thank you. And I should also mention, from a software perspective, I've actually found that sharing screens to help debug code is much better than walking up to someone's desk and both of you trying to stare at the same screen, hunched over, and they're scrolling too fast and you can't see what's going on. So there are actually a few pauses where now I think even if I was in the office with someone, maybe if we were like in the same room, I might still say, hey, can you hop on this Skype and I'll share my screen and we can debug this, or let's do some pair programming. I might just share my screen instead of having them come over and physically sit with me, just because it's easier to see your screen when you both have your own monitors and aren't hunched over each other. So maybe I wouldn't say positives, but I do think that'll be a change in a little bit of almost the culture for how software engineering is done in teams. Looks like we might have time for one more question. We do want to try to end at 11:55. So if you have another question, Matt, then
I have like 10. So,
okay. So
I
give us a
talk for a
softball
living.
one, easy one.
I've questioned you guys for years, so I'm ready to roll. Can you maybe talk about an obstacle that each of you overcame on your quest to become an engineer? And it could have been something from high school, something in college, something professionally. But everybody assumes that you guys are brilliant, and you are. But naturally, because you're brilliant, everything is easy, right? And I know that's not true. So maybe each of you could talk about something that made it a little bit difficult that you had to overcome to be where you are now.
Okay, yeah. I'm gonna stall a second so I can think. If anyone has one ready that they want to say, let me know. But I mean, I can just say not all of us are 100% brilliant. We're not all Jake Deems getting perfect on the math SAT. I was 60th in my class, I think, with like I mean, I still had a good grade. I think 93 unweighted and like 98 weighted. So, but I wasn't a over 100 top 10 student. I honestly think anyone can do it if you're interested in it. I wouldn't say if you're not interested in it just to push yourself just because for the salary or anything. But yeah, I'm gonna let someone else go if anyone's ready.
I can speak. Something that I learned throughout college is that not every I did well throughout all the way up through high school. Math and science just came easy to me. But then once I got to college, where the majority of my classes were just math and science, not everything came easy to me. There were certain classes that I did super well in just because I got it. But then there were still classes here and there where they were just more difficult. And to like my friends that I did homework with, they got it, but sometimes I just didn't. So you'll learn that there are, even though like I prefer mechanical over electrical or software, any of these things, there's still bits of mechanical that are more difficult for me than others. So learning that, I think something I had to overcome was I'm not going to get everything. You like to think that you're going to be able to know it all, but that there's still lots to learn, and it's okay to go in one direction in the particular disciplinary, and not be perfect and have amazing grades in every single class.
Yeah, I had a similar situation to Cecilia where all up until high school, I didn't even really have to study that much. I just got things, and it was a rude awakening my freshman year when I got a D actually in my calculus class, and I was just like, wow, maybe I'm not up for engineering. Maybe this is not for me. But just like Cecilia said, you realize you're not going to be good at everything. You might need to push a little bit more. You might need to take, you might need to get some tutoring. You know, everything's not going to come so easy to you. But if you really want it, it's something that you're really excited about doing, really interested in doing, you'll take the necessary steps needed to push forward and get it done.
Yeah, I had a similar situation to Carrie where I took AP Calc in high school, so I retook Calc in college just because it fit my schedule better. And it was really easy for me the first one. And then I took Calc 2 with the same professor. And I'm like, okay, this will be really easy too. I don't really need to do the homework. Only the tests were graded, so it was 4 tests for the whole year. That was the only thing that mattered. No homework. It didn't count or anything. The first test I got like a 40 on. I was able to pull back and get, I think, a C plus in the class, but it was definitely a rude awakening when the first I had him for my Calc 1 class as well, and I had gotten above a 90 on every test, and I didn't study at all. And then I went to Calc 2 with the same attitude, same professor, and I just got destroyed by the first test. It was horrible. So then I realized I needed to change my study habits and just adapting to the situation.
Yeah, I think for me, I think burnout was a big issue. Um, when I went to school for the semester, I felt like I was spending every waking moment thinking about my classes, doing my homework, doing studying, reading, um, signing up for extracurricular stuff to the point where like I was so stressed out that like I wouldn't want to go back for the next semesters. So I think a big thing is to kind of relax a little bit, to kind of do um, do what you're interested in. Take classes that you're interested in. Um, study when you can. Study and look for those opportunities. And take club or participate in clubs that you're interested in, but don't over sign up for stuff. And yeah, I guess I felt like there was more in college where I felt like the school and personal life was mixed than now with the work and personal life. I felt like if I did a better job of separating the school and the personal life, I would have had a better outlook in college.
Oops, I think I'm unmuted now. Okay, awesome. Thank you, everyone. We are going to have to wrap it up. So I don't know if there's any closing things that people want to say real quick. We want to be finished within the next minute or two. Um,
I'll bookend it if you don't mind. I sincerely want to thank you guys for your time and your effort you put into this. I know people are watching and will watch, after this, and I know that you're definitely going to make an impact. I know you took time out of your day. I know that can be really difficult, especially when you have projects or, workflow or whatever hanging over you. So, from everybody through me, thanks. And on a personal level, as the father of a son who is going into engineering, who's been accepted to Clarkson and Buffalo, and we're waiting for RIT. So I think that addresses all 4 of you. Thank you for giving me stuff I can bring home and say, like, see, you should do your homework, even if the class is just tests. Or, you should be signing up for clubs and things like that. So on a personal level, thank you for helping me, like, harass my son. And at the same time, I have students that are watching this right now too, and I know that they appreciate the time you put in because they had some really good questions, and I know they appreciate you too. So thanks again.
Awesome.
What
Thank you.
what engineering field is he going into?
He's looking at mechanical.
Boo. No,
So-
just kidding.
He
Well,
would do
tell him
the
good
auto-
luck.
the auto
Yeah.
program at school, so he likes getting his hands dirty, but he takes computer science and calc, so we're hopeful.
There you go.
Thanks.
All right. Well, thank you.